It also suggests a test for independence. And the test for independence would be to ask the question, is the probability of A the same as the probability of A given B? Incidentally, speaking of independence, what was Mendel's great contribution? He's a Christian monk from Switzerland, I guess. What did he do? He did something in genetics, right? And what specifically was it that he discovered about his genes?
Dominant and recessive genes.
You know, he uncovered dominant and recessive. He alleged that there were dominant and recessive genes, and the way he did that was by crossing green and yellow peas, which is a color trait, with peas that were smooth or wrinkled. And so he set up these little two-way tables to see whether or not color was determinative in any way of the texture of the skin on the pea. So basically what he had to do was look at whether or not the marginal probabilities were the same as the conditional probabilities, and then he inferred something about genes and alleles and dominant traits and so on and so forth. So he's the grandfather of modern genetics. What else do you know about Mendel and his genes? Anything? He's a monk, right? Monks are honest. Sure, the sun comes up in the morning, right? They got to go to confession. If they go to mass every day, and they have to go to confession every day, confess their sins, right? Well, there's the suspicion that Mendel wasn't all that honest. His test statistics from his pea experiments were too good. So people think that he cheated a little bit. He knew the result that he wanted, and so he fudged the data a little bit to make sure that he got it. He would fit right in some of the natural science departments at Harvard. They've had many scandals at Harvard over the last 25 years where the different biologists in the departments there have caught cheating.
There's definitely a light, the light was better over here, so he's trying to fix the data.
Yeah, that would be one way to do it. Hakjun, what's the addition rule in probability? We know what the multiplication rule is. Right. So if I said to you, if I was standing in the back of the room and I said, what's the probability of landing in A or B? Because there's a positive intersection between them, you don't want to count some of the points twice. So it's the probability of getting A plus the probability of getting B, and then we subtract off one set of double counting. Okay, a random variable is a mapping from a sample space to the real line. So the sample space, if we have a handful of 5 coins, the sample space is all the possible outcomes that we could get when we toss our 5 coins up in the air and they land on the table. We get no heads, 1 head, 2 heads, 3 heads, 4 heads, 5 heads, so on and so forth. So the sample space is all the possible enumerations of head-tail combinations, giving us we can tell the difference from one coin to the other. Strategy. So the sample space of all the possible enumerations of head-tail combinations that we get when we toss the 5 coins up in the air. And a random variable is the mapping of all of those points in the sample space to the real line. I can get no heads, 0, 1, 2, 3, 4, 5. No, I haven't said anything about the density. All I did was say that the random variable is a mapping from the sample space to the real line. Now I ask the question, what's the probability for that random variable? I don't need to know the distribution of the random variable in order to understand how the random variable is constructed. First I construct it, and then I ask how to distribute it. So, Huan Chen, what are the 3 axioms of probability? it could be any experiment, but if you want 20 plus, sure. What are the three axioms of probability? What's true about every probability distribution on Earth? What are the three axioms of probability? It's just like, are you an econ student? No. Who is an econ PhD student? Now nobody wants to own up to it. I know there are some in here because they have mentioned. What are the axioms of preferences? Oh, Laura is an econ student. What are the axioms? When you were learning about indifference curves over there on the bad side of town, when you were learning about indifference curves, what were the three axioms of the preference relations that allow you to draw the indifference curves the way you did? Choose a rational, okay. But, yeah, preferences are convex. More is preferred to less. Preferences are reflexive and transitive. And what's the last one? Transitive. So they're reflexive and transitive. They are so they're convex. They're transitive. They are reflexive. More is preferred to less. And definitely transitive. So what are the axioms of probability? Oh no, I was on one thing. So now you understand what I mean by axioms. The things that we believe to be absolutely true, from which we then can put together a construct. So what are the axioms of probability? What three things are true? Every probability distribution is particular. Think about David's coin thing. He had one coin and he tosses it up in the air. What's the probability of the coin landing head up? What's the probability of it will land tail up? And so therefore, some of the probability of one is 1. And let's give him 2 points. Let's give him 2 points. Let's put together a set that we'll call A. And A is all the possible subsets of the sample space with a 2-coin toss. You understand what A is a set of all possible subsets of 2-coin toss. So one subset of the sample space